Hi friends, welcome. Today we're going to talk about ML tooling. As the machine learning industry evolves, we have seen more and more tools. In addition to the basics like TensorFlow and PyTorch, nowadays we have JAX. In addition to those training framework, you also have those assistant tools like TensorBoard, MLflow, and Weight and Bias. Those tools helps you keep track of your metrics so that you can pick the best model. You can also use these tools to scale your inference into multiple nodes. You can also scale your training into multiple nodes. So these tools including Ray. You can use Ray for orchestration and deployment. You can also use Airflow plus Kubernetes, as well as Kubeflow. Here's our agenda today. We'll talk about all those tools from the ML pipeline perspective. We'll start with an overview of ML pipeline, and then we'll talk about the details of each component and the tools that can be applied in each component. At the end of this video, we'll talk about the decision factors. Here's an overview of the ML pipeline. So you usually start with data collection. There you go, you have the raw data. You pass the raw data to data processing, where you cook the data to be digestible for your model training framework. And then you enter this feedback loop, where you train the model, record the metrics, then you evaluate, find out the best model. And then if it's not good enough, you iterate until you figure out the best. Once you have the best model, then you save your model artifact somewhere so that it can be used for inference later on. Usually, they can reuse data collection and data processing stage. For example, at training stage, it's okay you have higher latency, but the inference pipeline probably has a major focus on high scale and low latency. Let's now focus on the data collection stage. Why do you need data collection? It's mostly because you need better features. And to get better features, you most likely need features from different sources. Some of your features can be from CSV file, your logs, and some of features can be from certain databases. For example, if you are doing some pre-training, you probably are using certain parameters from other models. Those parameters are saved in some databases. Also, it could be that you are using some event-based features. So you gather all those features, doing an aggregation, and then you also do some basic data validation to figure out if those features are as you have expected. With all those things done, you will now have the raw data. So it seems like a trivial stage, but if you have a large volume of data, the way to do data collection stage, the aggregation stage and the data validation stage is usually via Spark or Beam. And next, you have the data processing stage. So after you have the raw data, you need to cook the data. What do I mean by cook the data? You usually do two things. You do dataset partition, and you also do the feature processing. Partition refers to when your dataset is too big to fit into the memory. You want to chunk your data into multiple partitions so that it can sit in different instances. In PyTorch, they have this type of dataset called iterable dataset. An implementation of iterable dataset in PyTorch is web dataset. So if you ever want to implement partition dataset, a web dataset is something to try. In addition to data partitioning, you also need to figure out the feature processing. It is because your raw feature could possibly contain categorical features, sequence features, and some scalar features, because you need to apply different transformation for them. So that's the part of thing you need to do to actually cook your data. So some relevant tools here are Pandas and Desk. So they are used when your dataset size is small. But once you have larger dataset, you want to consider using Ray, Beam, and Spark. So once you have processed your data into a desired format, it is ready to be digested into your model training. Some popular frameworks are PyTorch, TensorFlow, and JAX. PyTorch and TensorFlow are especially popular. PyTorch is known for being user-friendly, and TensorFlow is known for high performance due to the fact that it has a static graph. The framework is newer. It has the good side of both PyTorch and TensorFlow, but also it's a newer framework, so it has less community compared to these two frameworks. So I also listed monitoring, logging, and experiment here, because this is the thing you have to incorporate into your training code. Some relevant tools here are Weight and Bias, MLflow, and TensorBoard. They have their own APIs, and when you are training, you need to add the logging code into your training loop. With that, at this stage, we think you already have a decent model. So next task is to set up the orchestration. For simplicity, I define orchestration here is to set up stack dependencies. For example, your model inference need to wait for data collection task, or your model inference need to output certain output files. So you need to set up dependency stack for this. To do so, you can use Airflow as scheduler, and you can use Kubernetes for orchestration. Some alternatives are Kubeflow and Ray. The difference of Kubeflow and Ray, in my opinion, is that Kubeflow is based on Kubernetes, so it's relatively high level, whereas Ray is lower level orchestration and deployment. Both Kubeflow and Ray can help you control the resource allocation at different stage and different component. So if I want simplicity, I will go for Kubeflow. If I want flexibility and comprehensiveness, I would go for Ray. So lastly, decision factors. I think for most people, you would really want to figure out what is the pain point right now. A lot of time for me, the pain point is that my model isn't training fast enough, my model isn't scalable enough. So those are the things that can be resolved by tools such as Ray. For example, a common scenario is that the CPU and the GPU computation. Sometimes the CPU is too fast, that your data loading is too fast so that you have GPU shortage. Sometimes you have your CPU not efficient enough so that your data loader isn't fast enough to feed data into GPU. This can be solved by using Ray data. You can allocate CPU workers for your data loading process to further scale up. Or you can use DALL-E. DALL-E is open source library provided by NVIDIA. So with DALL-E, you are able to accelerate your data loading process using GPU. You can either isolate the data loading process using Ray, using more GPUs, or you can accelerate by replacing the previous CPU process using GPU. Another common thing to look into is whether the tool is open source or enterprise provider. Because we need to look into the long-term maintenance, right? Next thing to look into is whether the tool is open source or does it have an enterprise provider. If you have people ready to dive into the code, open source is fine. But if you are someone who has money or don't have much time to dedicate into the code, you can use enterprise provider of the tool. Next, I want to talk about community support. Because as the code piles up, you can't solve every problem yourself. So it is always good to adopt tools that has rich community support, so that when you have problem, this problem has been encountered by somebody else. And best of all, if they already have an answer for it. Lastly, I want to talk about integration. So notice that many open source tools are started by some certain companies. For example, TensorFlow, JAX, TensorBoard, Kubeflow, they're all from Google. If you already use Google tools, they probably integrate well with more Google tools. But if you're on the other side of the Tensor world, you use PyTorch and then use Llama. So maybe it's better to adopt more PyTorch tools, because Llama and PyTorch are both from Meta. So if you're trying to inference like Llama model, PyTorch would be a better choice. Now, because obviously PyTorch is Llama's native language. That's all I have for today. Let me know what you think.